Hi, everyone. My name is Wade Gong. This is Justin Gehr, and this is Monica He. Together, we built Saga, a mobile app that allows users to team up and compete in local scavenger hunts called Stories. Stories are comprised of inquisitive riddles, augmented reality minigames, image recognition challenges, and geolocation puzzles. We decided to build this app in particular because we all share an interest in the outdoors, traveling, and games. To get started, we're going to demonstrate what it's like to add friends and begin a story. First, I'll log in and add a few friends. Once they've accepted, I'll browse and select a story, and then invite a few friends who I'd like to play with. Once they've joined, we can go ahead and get started with our story together. Each story is broken down into a series of chapters, and each chapter contains a number of puzzles. In our first chapter, we've included a geolocation puzzle where the team needs to move to a specific location in order to advance in the story. We enabled this functionality using a combination of React Native background geolocation, GeoLib, and Redux. Once the team is in the designated geofence, we'll be able to pass the puzzle and continue along with our story. In the next chapter, Justin will walk through some of the augmented reality mini-games and describe how we built them.
Thanks, Wade. I'm sure many of you have heard of Pokemon Go. It has brought a lot of attention to augmented reality in the past year, and it was our inspiration for incorporating AR into our app. An initial challenge for our AR game was finding a way to superimpose computer-generated images into the user's real-world camera feed. We arrived at our solution by utilizing the built-in gyroscope in phones. We created an algorithm that, given an X and Y rotation rate, it will calculate an image's current X and Y offset. We use this offset to re-render the image through Redux to bring it either towards or away from the user, depending on their orientation to the image itself in real space. We have currently implemented 3 different AR puzzles. The most challenging of the 3 was where we had to drag one AR object over to another AR object. We needed to keep track of where the user drags an image and where the AR image is in the real world. We again were able to use the offsets we calculated combined with some logic to determine if the 2 objects collided in the physical world. Now I'm going to hand the mic over to Monica to talk some more about image recognition.
Thanks, Justin. The image recognition puzzle was built using 3 Google Cloud services. Vision is a TensorFlow implementation of deep convolutional neural networks. Storage handled our uploaded images, and Cloud Functions connected these services to our Firebase backend, allowing us to take a picture, run it through Vision, and check if the photo you take matches the puzzle answer. Both the image recognition and the geolocation add a customizable but scalable aspect to the traditional concept of a scavenger hunt, as teams no longer require a human moderator to facilitate each game. Firebase allowed us to do this collaboration in real time. Each user is notified when someone else on the team finishes a puzzle, or when the entire chapter has been solved. Designing the connection between this cloud backend and React Native was challenging, and after a lot of architectural iterations, we converged on Firebase references in a wrapper React container, listening to changes in the database initiated by our lower components, our buttons, and passing puzzles. The logic for journey and team creation, putting puzzles into stories, and even friending was somewhat complicated, and using Redux greatly simplified the flow. Calculated use of Cloud Functions often provided an alternate and elegant solution to rare but mass updates to game status during authentication and making calls to external APIs. Thanks for taking the time to learn about Saga.